Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about a simple problem: count good nodes in a binary tree. Its index is 1448 and it is a medium type problem of the LeetCode, but still I categorize them as a simple one because this is really a simple problem. You need to know, just find it out the number of good nodes considering some basic observations. Okay, so without going into that deeper thing, let's discuss this problem and we will together build up the best solution for this problem. Given a binary tree root, a node x in the tree is named as good. That is a node is said to be a good node if and only if in the path from root to this current node there are no nodes with a value greater than x. If you look at this statement in some other terms, it means that if we are just saying that this current node is a good node, then all the nodes lying on this path from root to the current node, this current node value is like the greatest one. You can also understand this one. Okay, so let's understand this problem with the help of example. So let me move further to this my open board. Yeah. Okay. Yeah. So what I'm going to do is like, let me pick out this example. Okay. Okay. Add to the current page. This is not good. Okay. So go to the desktop and use this as cut one. Yeah, it is done. Okay. So what I'm going to explain it about is like, suppose we are at this node. Okay. So we are at this node. And if we have been asked that, or let's say we are going to claim that this node is a good node. So it is a good node if and only if the path from this root node to this node, that is the path you can see this, from this to this, from this to this node is holding the greatest value. That is, all the nodes lying on this path have the value less than equal to this current node value. Current node value. You need to check it out this condition, and if it holds true, it means that you are going to say that yes, this is a good node. How we are going to do that? Okay, so we can easily understand that the root node is always going to be a good node because the path from root to root itself has the value like 3 less than equal to 3. Yes, it is true. So this is always a good node. Okay, so what about the other nodes? How we are going to say about that? So the reason is like very simple: traverse every possible case, like recurs for every node. Okay, recurs for root left. First you're going to, in the left subtree you can go in any of them, it doesn't matter. And then we are going to have visiting the right subtree of this current node, root right. Okay, now the thing is like, when you are at, let's say, at this left subtree of this current root node. Okay, so you need to compare these two values, right? That is all the nodes that are lying on this path. Okay, so in this case you have to be very much clear that you're passing the new parameter, and new parameter of the max of current max value. That is okay, so what is the current max value? That is up to this point, you can see it is 3, plus if you are moving on to the like, yes, current max value is like nothing because we are starting with this root node, so we are going to pass it out 0 or int minimum. It doesn't matter. You can see that the nodes value is like minus 10 raised to the power 4, I think. So we will be starting from int minimum. So max of, like, if you are starting at this point, max of int minimum and this current node 3. Okay, so it will be passing as the 3 value. Similarly, we are going to move on to the right subtree and passing 3 value. And what about when we are at this node, let's say? Okay, so when we are at this node, when we are going to move to the left subtree of this current node, you need to be careful that you are passing this entire maximum value among all these nodes. How we are going to do that? Suppose we are at this node, maximum value up to this node is like 3 and 1 is, sorry, only 3 because we are up to this point. Okay, so when we are at this point, maximum value up to this one is 3, and when we are going to move to the left subtree of this current node 1, Then we are passing it out as root left and max of, what is the maximum value up to this point? It is 3, and including this node is 1, so it would be going as 3. Okay, and similarly if you are at this node, max value up to this node 4 is only 3, and when we are going to move to the left subtree, you are going to pass a max of 3 and 4, and when you are going to move to this one also, you are going to pass it out as max of 3 and 4. Okay, so in this case, when we are at this one, you would have the value of max of 3 and 4, and you need to check it out whether max of 3 and 4 is going to like less than equal to 5. Yes, it is. So we are going to say yes, this is a good node. So the implementation would be like very much simple. You can see over here. If it is a root is null, just return. Otherwise, if current max is less than equal to root val according to the problem description, increment your answer, and if it is done, move further to the solving left subtree and right subtree, and passing the current max as like current max is going to change for every path. So max of current max and the current root value, and this is the answer reference. I am passing it out, which would be incremented when this condition is going to be satisfied. Note that in the good note function I am initializing as answer as 0, and passing the parameter solve, root, int minimum, and the answer. This is passed as reference, you can see over here, and finally return the answer. This will give you all test cases passed. So this is like very simple solution. So you need to be like aware about these concepts of in a binary tree. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to YouTube channel for latest updates. Thank you for watching this video.